In the quiet hours when darkness blankets the earth, radio telescopes stand like sentinels against the star-filled sky, their massive dishes turned toward the infinite expanse above. They listen constantly, these mechanical ears, sampling the cosmic symphony of radiation that flows from distant galaxies, pulsing stars, and the empty spaces between worlds. Most of what they hear is silence, punctuated only by the gentle hiss of background radiation, the whispered remnants of the universe's own creation. But sometimes, in that vast ocean of cosmic noise, something different emerges, something that doesn't belong to the natural rhythms of space, something that carries the faint possibility of intention, of intelligence, of a message crafted by minds not our own. It was on one such night in 1977, in the rolling hills of Ohio, an astronomer named Jerry Ehman encountered a signal so extraordinary, so unlike anything ever detected, that he could only scribble one word beside it on his computer printout. That word would become legend, spoken in hushed tones by scientists and dreamers alike. A single exclamation that captured humanity's deepest hope and most profound question. What if, in all that cosmic silence, someone was trying to speak? I'm curious where you're listening from tonight, and what hour finds you seeking these cosmic mysteries. It's truly wonderful to have you here with me as we explore this incredible story together. Now, let's begin. Jerry Ehman was not the kind of man who expected fame. Born in 1937 in rural Wisconsin, he had grown up with a quiet fascination for mathematics and the orderly patterns that governed the natural world. By the time he arrived at Ohio State University in the 1960s, he had already developed the patient, methodical temperament that would define his career in astronomy. He was drawn not to the glamorous work of visual observation, peering through optical telescopes at distant galaxies, but to the more subtle art of radio astronomy, listening to the invisible signals that permeated the cosmos. Ehman possessed the rare quality essential for SETI research, an almost infinite capacity for routine. Day after day, week after week, he would examine computer printouts filled with numbers and letters, searching for patterns that didn't belong to the natural symphony of space. It was work that required both technical precision and a kind of meditative discipline, the ability to maintain focus while sifting through vast quantities of data that revealed nothing extraordinary. The Big Ear radio telescope, where Riemann conducted his research, was located in the rolling farmland of Delaware, Ohio, about 20 miles north of Columbus. From the outside, it hardly looked like humanity's window to the stars. The facility consisted of a flat rectangular reflector, roughly the size of 3 football fields, lying horizontal on the ground like a massive concrete mirror. Above it, a tilted parabolic reflector focused incoming radio waves down toward the receiving equipment. There were no soaring dishes or gleaming domes, no dramatic silhouettes against the sky. Big Ear looked more like an abandoned construction project than one of the most sensitive listening devices ever built. But appearances were deceiving. Despite its humble appearance, Big Ear was capable of detecting radio signals from sources billions of light-years away. The telescope operated by allowing the Earth's rotation to slowly sweep different patches of sky across its field of view, methodically sampling the radio spectrum as our planet turned. It was a patient and interminable process, perfectly suited to the temperament of researchers like Ehman, who understood that the universe rarely revealed its secrets in dramatic fashion. The search for extraterrestrial intelligence, or SETI, had been a formal scientific discipline for less than 2 decades when Ehman began his work. The concept was both simple and profound. If technological civilizations existed elsewhere in the universe, they might be detectable through their radio emissions, either from their normal communications or from deliberate attempts to signal their presence to other intelligence. The challenge was distinguishing such signals from the constant background noise of natural cosmic radio sources, from pulsars and quasars, to the leftover radiation from the Big Bang itself. Ehman's daily routine involved examining computer printouts that recorded the intensity of radio signals detected across different frequencies and positions in the sky. The data was represented in alphanumeric code, with numbers and letters indicating signal strength. Most of the time, the printouts showed only the gentle variation of cosmic background noise, occasionally punctuated by known sources like radio galaxies or the regular pulses from neutron stars. The work required extraordinary attention to detail, and an intimate familiarity with what constituted normal versus anomalous readings. The Big Ear telescope scanned 50 different frequency channels simultaneously, building up a comprehensive picture of radioactivity across a significant portion of the electromagnetic spectrum. Each position in the sky was observed for exactly 72 seconds, as the Earth's rotation carried it through the telescope's beam. The data was processed by IBM computers and printed out on continuous form paper, creating physical records that astronomers could examine at their leisure. It was this deliberate, methodical approach that defined the culture of Big Ear. There were no dramatic all-night vigils or frantic phone calls when interesting signals appeared. Instead, researchers like Ehrman would typically examine data that was several days old, allowing time for the computers to process the observations and generate clean printouts. This delay meant that any truly extraordinary discoveries would be made not in the heat of real-time observation, but in the quiet hours of careful data analysis. August 19, 1977 began like any other day for Jerry Ehrman. He arrived at the Big Ear facility in the morning and settled into his routine of examining the latest batch of computer printouts. The data he was reviewing had been collected several days earlier, during the telescope's routine sweep of the constellation Sagittarius. As always, he worked with a red pen in hand, ready to mark anything unusual that caught his attention. Most of what Ehrman saw that morning was entirely predictable. The printouts showed the familiar patterns of cosmic background radiation, the occasional spike from a known radio source, the steady rhythm of normal astronomical observations. He worked his way through page after page of data, his trained eye automatically scanning for anything out of place. The work was meditative, almost hypnotic, requiring just enough attention to identify anomalies while allowing the mind to settle into a comfortable rhythm. Then on one particular page corresponding to observations made on August 15th, something extraordinary appeared. In the sequence of alphanumeric characters representing signal strength, Ehrman noticed a pattern that made him stop and look more carefully. The normal background level was represented by 1s and 2s, occasionally rising to 3s or 4s for known sources. But here in the data from radio frequency 1420 MHz was a sequence that climbed dramatically higher. 6, then E, then Q, then U, then J, then 5. In the coding system used by Big Ear, each character represented increasing levels of signal intensity. The sequence 6EQUJ5 indicated a signal that had started strong, grown much stronger, peaked at an extraordinary level represented by the letter U, and then faded back to normal background levels. The entire event had lasted exactly 72 seconds, precisely the time it took for a point source in space to transit the telescope's beam, as the Earth rotated. Ehrman stared at the sequence, his pulse quickening. In all his years of examining data, he had never seen anything like this. The signal was 30 times stronger than the background noise, far too intense to be explained by normal cosmic sources. More importantly, its behavior perfectly matched what SETI researchers had theorized an artificial signal might look like: a narrow-band transmission from a fixed point in space, rising and falling as the Earth's rotation carried it through the telescope's beam. Without hesitation, Ehrman circled the sequence with his red pen and wrote a single word beside it in the margin: "Wow." It was an expression of pure scientific amazement, the reaction of a careful, methodical researcher confronted with data that defied easy explanation. In that moment, with that simple exclamation, Jerry Ehrman had documented what would become the most famous signal in the history of SETI research. The discovery was made, not in the dramatic fashion of science fiction, with alarms sounding and researchers rushing to confirm an incoming transmission. Instead, it emerged from the quiet, patient work of a man who had spent years listening to the sky, who possessed the knowledge and experience to recognize when something truly extraordinary had been detected. In the silent hours of that August morning, examining data that was already days old, Jerry Ehrman had found what might be humanity's first confirmed contact with intelligence from beyond our world. To understand why the sequence of characters that Jerry Ehrman circled on that August morning was so extraordinary, we must first explore the invisible universe that radio astronomers inhabit daily. Unlike the familiar night sky visible to our eyes, the radio cosmos is a realm of signals and frequencies, a hidden landscape where dying stars whisper their final messages, and distant galaxies broadcast the stories of their violent births across billions of years. Radio waves are simply light that our eyes cannot see. Electromagnetic radiation with wavelengths much longer than the colors of the rainbow. These waves travel at the speed of light through the vacuum of space. carrying information about their sources and the subtle variations of their strength and frequency. When they reach Earth, radio telescopes capture them much like a satellite dish receives television signals, focusing the faint cosmic transmissions onto sensitive receivers that convert them into data astronomers can analyze. The electromagnetic spectrum extends far beyond what we perceive as visible light. While human eyes detect only a narrow slice of radiation, roughly from violet at 400 nanometers to red at 700 nanometers, radio waves occupy wavelengths measured in centimeters, meters, and even kilometers. This radio spectrum is vast, containing thousands of distinct frequency channels, each potentially carrying different information about the cosmos. In radio astronomy, signals are typically measured in terms of their frequency, expressed in units called hertz. 1 hertz represents 1 wave cycle per second, while a megahertz represents 1 million cycles per second. Different frequencies penetrate Earth's atmosphere with varying degrees of success, creating windows of transparency that radio astronomers exploit to study the universe. The frequency range from roughly 300 to 3000 megahertz represents one such window, relatively free from atmospheric interference and terrestrial radio transmissions. Within this radio window lies a frequency of particular significance, 1420.406 megahertz. This precise frequency corresponds to a fundamental property of hydrogen atoms, the most abundant element in the universe. When hydrogen atoms undergo a specific quantum transition, they emit radiation at exactly this frequency, creating what astronomers call the hydrogen line or the 21-centimeter line, named for the wavelength of this radiation. The hydrogen line holds special meaning for anyone contemplating communication with extraterrestrial intelligence. Since hydrogen exists everywhere in the cosmos, any technologically advanced civilization would inevitably discover this frequency through their study of physics and astronomy. Some theorists have suggested that this universal constant might serve as a logical choice for interstellar communication, a frequency that any scientific civilization would recognize as significant and monitor routinely. When the Big Ear telescope detected the signal that would become known as the WOW signal, it was operating at precisely this hydrogen line frequency. The signal appeared at 1420.356 MHz, remarkably close to the theoretical hydrogen line, well within the range that could be explained by the relative motion between Earth and the signal's source. This frequency match was the first indication that something unusual had been detected. But frequency alone did not make the signal extraordinary. Radio sources throughout the universe naturally emit radiation at the hydrogen line frequency. Clouds of interstellar hydrogen, regions of star formation, and various galactic structures all produce 21-centimeter emission. What distinguished the WOW signal was not what frequency it used, but how it behaved at that frequency. The strength of the signal was unprecedented. In the coding system used by Big Ear, normal cosmic background noise typically registered as intensity levels of 1 or 2 on the alphanumeric scale. Moderately strong radio sources might reach levels of 3 or 4. The most powerful known sources rarely exceeded level 6, but the WOW signal peaked at intensity level U, representing a signal approximately 30 times stronger than the background noise. This extraordinary strength immediately ruled out most natural explanations. No known astronomical phenomenon could produce such intense narrow-band emission at the hydrogen line frequency. Quasars and radio galaxies, among the most powerful radio sources in the universe, emit their energy across broad ranges of frequencies, not concentrated in the narrow band observed. Pulsars produce regular pulses, but their signals sweep across a wide spectrum and follow predictable patterns, unlike anything detected on August 15th. The duration of the signal provided another crucial clue to its nature. The Big Ear telescope observed each position in the sky for exactly 72 seconds, the time required for Earth's rotation to carry a fixed celestial source through the telescope's beam. The WOW signal rose from background level, reached maximum intensity, and faded back to normal over precisely this 72-second interval. This behavior perfectly matched what astronomers would expect from a narrow beam transmission originating from a fixed point in space. If the signal had been generated by terrestrial interference, such as aircraft or satellites, its duration would likely have been different. Aircraft signals typically last only seconds as they pass through a radio telescope's field of view, While satellite signals might persist for different time periods depending on the satellite's orbit and the direction of its transmission, the precise 72-second duration strongly suggested that the source was located far from Earth, appearing stationary against the background stars. The bandwidth of the signal provided additional evidence of its artificial nature. Natural radio sources typically emit across relatively broad ranges of frequencies, creating signals with significant bandwidth. The WOW signal, however, appeared to be concentrated within an extremely narrow frequency range, less than 10 kHz wide. This narrow bandwidth suggested a highly focused transmission, the kind of precise frequency control that typically indicates artificial origin. In electronics and communications, narrow bandwidth is often a sign of intelligent design. Natural processes tend to be inefficient, spreading their energy across wide frequency ranges. Artificial transmitters, designed by intelligence for specific purposes, concentrate their power within narrow bands to maximize their effectiveness and minimize interference. The remarkable narrowness of the WOW signal's bandwidth was consistent with an artificial, engineered source rather than a natural astronomical phenomenon. The polarization characteristics of the signal, though not fully documented due to the limitations of Big Ear's equipment, also provided hints about its nature. Natural radio sources often emit unpolarized radiation, with electromagnetic waves oriented randomly. Artificial transmissions, particularly those designed for long-distance communication, are frequently polarized to improve their propagation characteristics and reduce noise. While the polarization data for the WOW signal remained incomplete, what evidence existed suggested properties more consistent with artificial rather than natural emission. Location of the signal in the sky added another layer of significance to the detection. The signal appeared to originate from the constellation Sagittarius, in the direction of the galactic center where stars are densely packed. This region of space contains hundreds of billions of stars within a relatively small area of sky, dramatically increasing the probability that any given direction might harbor planetary systems and, potentially, technological civilizations. Perhaps most intriguingly, the signal appeared to originate from empty space, not from any known star system. Careful analysis of the signal's position revealed that it did not correspond to any catalogued astronomical object. There was no star, no galaxy, no known radio source at the precise location from which the signal seemed to emanate. This absence of an obvious natural source further deepened the mystery and strengthened the case for an artificial origin. The combination of these characteristics created a pattern unlike anything previously detected by SETI researchers. The hydrogen line frequency suggested knowledge of fundamental physics. The extraordinary intensity indicated a powerful focused transmission. The 72-second duration confirmed a source fixed in space, far from Earth. The narrow bandwidth implied artificial generation. The absence of any known natural source at the signal's location eliminated most conventional astronomical explanations. Scientists trained in the careful evaluation of evidence found themselves confronting data that seemed to check every box on their theoretical list of what an artificial extraterrestrial signal might look like. The WOW signal possessed all the characteristics that SETI researchers had predicted such a transmission would exhibit, appearing exactly as their theories suggested. First contact might manifest itself in the cosmic radio spectrum. Yet, for all its extraordinary properties, the signal raised as many questions as it answered. If it was indeed artificial, why did it appear only once? If it represented an attempt at communication, why was there no repetition, no pattern, no obvious message content? If it originated from an extraterrestrial civilization, what did its detection mean for humanity's place in the universe? These questions would haunt researchers for decades to come, transforming the WOW signal from a simple astronomical observation into one of the most profound mysteries of modern science. In those 72 seconds of transmission, captured on a routine night in rural Ohio, lay implications that could reshape humanity's understanding of intelligence, communication, and our cosmic neighborhood forever. The discovery of the WOW signal created an immediate paradox for Jerry Amon and his colleagues at Big Ear. On one hand, they possessed what appeared to be the most compelling evidence ever recorded for an artificial extraterrestrial transmission. On the other hand, they faced the sobering reality that the signal had appeared only once, captured in a routine data collection that had occurred 3 days before anyone realized what had been detected. In the days following Amon's discovery, The Big Ear facility hummed with unusual activity. Researchers abandoned their normal routines, focusing all their attention on the patch of sky where the signal had originated. The coordinates were precise. Right ascension, 19 hours 25 minutes. Declination -26 degrees 57 minutes. Deep in the constellation Sagittarius. If the signal represented genuine communication from another world, logic dictated that it might repeat. That whoever or whatever had transmitted it might send additional messages. The first attempts to relocate the signal began within hours of its discovery. Big Ear's operators redirected the telescope's scanning pattern, spending far more time than usual monitoring the specific region where the transmission had appeared. They expanded their observation window, watching not just the exact coordinates but the surrounding area, accounting for possible errors in position or the natural drift of celestial objects through space. Days passed in careful observation. The telescope gathered data from the target region with methodical precision, recording every fluctuation in the cosmic radio spectrum. Researchers examined each new batch of computer printouts with heightened attention, searching for any sign that the extraordinary signal had returned. They varied their approach, monitoring during different times of day, adjusting their frequency settings, and employing different analysis techniques to ensure they weren't missing anything. But the sky remained silent. Where once an intense narrow-band transmission had blazed across the radio spectrum, now only the familiar whisper of background radiation filled the receivers. The source, whatever it had been, showed no signs of renewed activity. The silence was not merely disappointing. It was scientifically problematic. In the rigorous world of astronomy, extraordinary claims require extraordinary evidence, and extraordinary evidence must be reproducible. The scientific method demands that significant discoveries be verified through repeated observation. A single detection, no matter how compelling, cannot stand alone as definitive proof of anything, particularly something as revolutionary as communication from another civilization. The absence of the WOW signal in subsequent observations immediately complicated any claims about its significance. The protocols for verifying astronomical discoveries had been established through centuries of careful scientific practice. When a new comet was discovered, other observatories were notified to confirm its existence and track its movement. When pulsars were first detected in the 1960s, initially suspected of being artificial signals, their regular repetition allowed multiple facilities to study them and ultimately determine their natural origin. But the WOW signal offered no such opportunity for confirmation. Word of the discovery began to spread slowly through the tight-knit community of SETI researchers. Jerry Amon and his colleagues were careful not to overstate their claims, presenting the detection as an intriguing anomaly rather than definitive proof of extraterrestrial intelligence. They shared their data with other radio astronomy facilities, hoping that someone might have detected similar signals or could offer alternative explanations for what had been observed. The initial reaction from the broader scientific community was one of cautious interest mixed with healthy skepticism. SETI research occupied a delicate position within mainstream astronomy. While the search for extraterrestrial intelligence was scientifically legitimate, it also attracted considerable public attention and speculation that made many researchers uncomfortable. The field needed to maintain strict scientific standards to preserve its credibility, which meant treating even the most compelling detections with appropriate caution. Other radio astronomy facilities around the world began conducting their own searches for signals similar to the WOW signal. The Arecibo Observatory in Puerto Rico, with its massive 300-meter dish, trained its receivers on the Sagittarius coordinates. The Very Large Array in New Mexico, with its 27 interconnected radio telescopes, joined the search. Facilities in Australia, Europe, and the Soviet Union all contributed observation time to the effort. These international search efforts represented an unprecedented level of cooperation in SETI research. The potential significance of the WOW signal motivated astronomers to set aside national rivalries and institutional competition, focusing their collective resources on answering a fundamental question about humanity's place in the universe. If the signal was genuine, its implications transcended any single country or research program. The expanded search efforts revealed both the promise and the limitations of SETI research in the 1970s. While multiple facilities could monitor the sky simultaneously, their equipment varied significantly in sensitivity, frequency coverage, and analysis capabilities. Some telescopes excelled at detecting weak signals, but covered narrow frequency ranges. Others monitored broad spectral windows, but with less sensitivity. Coordinating these diverse capabilities to conduct a comprehensive search proved challenging. Months passed, then years. With no repetition of the wow signal, the initial excitement gave way to a more sober assessment of what had been detected. Some researchers began to explore alternative explanations, wondering if the signal might have been caused by terrestrial interference, equipment malfunction, or natural phenomena that hadn't been properly understood. Others maintained that the signal's characteristics remained consistent with an artificial extraterrestrial transmission, arguing that the lack of repetition didn't necessarily invalidate the original detection. The experience of searching for the wow signal prompted significant improvements in SETI methodology and technology. Researchers realized that detecting a signal was only the first step in a complex process of verification and analysis. They began developing rapid response protocols that would allow immediate follow-up observations of unusual detections. They improved their data storage and analysis systems, ensuring that interesting signals could be preserved and examined more thoroughly than had been possible with the wow signal. New technological approaches emerged from the lessons learned during the wow signal searches. Researchers began designing systems for simultaneous multi-frequency monitoring, recognizing that a transmission might shift frequencies or appear at multiple wavelengths. They developed more sophisticated interference rejection techniques, addressing the growing problem of human-made radio signals contaminating astronomical observations. They created better methods for sharing data between facilities, enabling coordinated international searches. The search for the wow signal also highlighted the psychological challenges inherent in SETI research. The work required extraordinary patience and persistence, the ability to maintain focus and enthusiasm despite repeated disappointment. Researchers had to balance scientific skepticism with openness to extraordinary possibilities, maintaining rigorous standards, while remaining receptive to phenomena that might challenge conventional understanding. As the years passed without any repetition, the wow signal began to occupy a unique place in SETI folklore. It represented both the promise and the frustration of the search for extraterrestrial intelligence. On one hand, it demonstrated that radio telescopes could detect artificial signals from space, that the technology and methodology of SETI research were sound. On the other hand, it showed how easily such signals could disappear, leaving behind only tantalizing hints of what might exist in the cosmic darkness. The failure to relocate the signal raised profound questions about the nature of extraterrestrial communication. Perhaps alien civilizations transmitted only briefly, sending focused messages towards specific star systems for limited periods. Perhaps the Earth had simply been fortunate enough to intercept a signal not intended for us, a stray transmission from a conversation between distant worlds. Perhaps the signal represented a unique event, a technological accident, or the final transmission from a dying civilization. Despite the lack of repetition, the search efforts continued with quiet determination. The coordinates in Sagittarius remained under periodic observation, monitored by telescopes around the world. Researchers understood that the absence of immediate repetition didn't necessarily invalidate the original detection. Communication patterns might operate on timescales far longer than human attention spans, with signals repeating every few years, decades, or centuries. The ongoing search for the wow signal became a testament to the patience required for SETI research, a reminder that the universe operates on its own schedule, indifferent to human expectations and timelines. In the silence that followed that extraordinary 72 seconds in August, researchers found both frustration and inspiration, disappointment and hope. They had glimpsed something extraordinary, something that suggested humanity might not be alone, and they remained determined to hear it again. In the decades that followed, Jerry Amon's remarkable discovery, scientists and researchers around the world wrestled with a fundamental question that kept them awake at night. What could possibly explain a signal so powerful, so precisely focused, and so tantalizingly brief? The search for answers led down numerous paths of investigation, each more intriguing than the last. As the scientific community attempted to understand whether humanity had truly received its first message from another world, the most conservative explanations began with terrestrial sources. The mundane but necessary considerations that every responsible scientist must explore before entertaining more extraordinary possibilities. Radio interference from human technology represented the most likely culprit, and researchers spent considerable effort investigating whether the wow signal could have originated from aircraft, military installations, or civilian radio transmissions. Commercial aircraft seemed an unlikely source given the signal's duration and behavior. Airplane radio transmissions typically lasted only seconds, as aircraft passed through a radio telescope's field of view far shorter than the precise 72-second duration of the WOW signal. Moreover, aircraft signals would show Doppler shift effects as the planes approached and receded, creating characteristic frequency changes that were not observed in the big ear data. Military radar systems presented a more plausible explanation, given their high power and potential for interference with astronomical observations. The United States Air Force operated several radar installations in the general vicinity of Ohio, and their transmissions could theoretically have been reflected or scattered in ways that might fool a radio telescope into detecting an apparent celestial source. However, careful analysis of military radar frequencies and operating schedules failed to identify any transmissions that matched the characteristics of the WOW signal. The possibility of satellite interference required more detailed investigation. By 1977, numerous satellites orbited Earth, many equipped with radio transmitters for communication, navigation, and scientific purposes. A satellite transmission reflected off the Moon, or scattered by atmospheric phenomena, might conceivably appear to originate from deep space. Yet satellite signals typically showed distinct patterns of frequency drift due to orbital motion, patterns absent from the WOW signal. Additionally, the signal's extraordinary intensity suggested a much more powerful source than any satellite transmitter of that era. Researchers also considered whether the signal might have resulted from equipment malfunction or data processing errors within the Big Ear facility itself. Electronic systems could occasionally produce spurious signals, computer glitches could corrupt data, and human error might misinterpret normal observations as anomalous. However, extensive analysis of the telescope's operation on August 15th revealed no equipment problems, software errors, or processing anomalies that could account for the detection. Atmospheric phenomena offered another potential explanation, though one that required increasingly complex scenarios to match the observed characteristics. The Earth's atmosphere could sometimes reflect radio signals in unexpected ways, creating apparent sources where none actually existed. Solar activity might enhance these effects, causing unusual propagation of terrestrial radio transmissions. But atmospheric reflection typically affected broad frequency ranges and created signals with different temporal characteristics than those exhibited by the WOW signal. Natural astronomical phenomena represented the next category of potential explanations, requiring scientists to consider whether known cosmic sources might occasionally produce signals resembling artificial transmissions. Pulsars, the rapidly rotating neutron stars that emit regular radio pulses, had been discovered only a decade before the WOW signal, and initially were suspected of being artificial beacons from extraterrestrial civilizations. However, pulsars produced signals with very different characteristics from the WOW signal. Pulsar emissions appeared at regular intervals, often with periods measured in fractions of seconds, and showed characteristic dispersion effects as their radio waves traveled through interstellar space. The WOW signal showed none of these telltale signs of pulsar origin, appearing as a single, isolated event, without repetition or dispersion. Solar activity provided another possible natural explanation, though one that required careful consideration of timing and frequency. Solar flares and coronal mass ejections could occasionally produce intense radio emissions, and under certain conditions, these might be focused or reflected in ways that could confuse radio telescopes. Yet the Sun was not in the direction of the WOW signal, and solar radio emissions typically covered much broader frequency ranges than the narrow bandwidth observed. Quasars and other distant galactic nuclei represented some of the most powerful radio sources in the universe, occasionally exhibiting dramatic changes in brightness that might conceivably produce signals resembling the WOW detection. But quasar variability typically occurred over much longer timescales, from days to years, rather than the precise 72-second duration observed. Moreover, quasars emitted across broad frequency ranges, unlike the narrow band character of the WOW signal. As researchers systematically eliminated conventional explanations, they were left to confront the possibility that had been implicit from the moment Jerry Amon circled those alphanumeric characters and wrote WOW in the margin. The signal might indeed represent evidence of extraterrestrial intelligence, a transmission from another technological civilization somewhere in the depths of space. The extraterrestrial hypothesis gained credibility through the process of elimination, but it also drew support from the signal's remarkable adherence to theoretical predictions about what artificial signals might look like. SETI researchers had spent years developing models for how extraterrestrial civilizations might attempt to communicate across interstellar distances, and the WOW signal matched these models with uncanny precision. The choice of frequency provided the most compelling evidence for artificial origin. The hydrogen line at 1420 MHz represented a universal constant that any scientifically advanced civilization would inevitably discover through their study of physics and chemistry. It marked a logical choice for interstellar communication, a frequency that would be recognized as significant by any species that had developed radio astronomy. The signal's location in the constellation Sagittarius added another layer of significance to the extraterrestrial hypothesis. This region of sky points toward the center of our galaxy, where stars are packed far more densely than in the solar neighborhood. Within just a few degrees of the WOW signal's coordinates lie hundreds of thousands of star systems, dramatically increasing the statistical likelihood that the region might harbor technological civilizations. The galactic center direction also held strategic significance for any civilization interested in communicating with multiple worlds simultaneously. The powerful transmission aimed from that region could potentially reach numerous star systems throughout the galaxy's spiral arms, making it an ideal location for a beacon designed to attract attention from emerging technological species like humanity. Conservative estimates suggested that several thousand star systems lay within the beam weight and distance range from which the WOW signal might plausibly have originated. Many of these stars were older than our Sun, potentially allowing more time for the development of advanced civilizations. Some resided in the galaxy's habitable zone, the region where liquid water could exist on planetary surfaces and life as we know it might evolve. More speculative analyses considered what type of civilization might produce such a transmission. The signal's extraordinary power suggested a technological capability far beyond current human achievements. To generate a signal detectable across interstellar distances required either massive transmitters or sophisticated beam-focusing technology, indicating a civilization with substantial energy resources and advanced engineering capabilities. The brief, non-repeating nature of the transmission hinted at several possibilities. Perhaps it represented a survey beacon, systematically scanning different regions of the galaxy for signs of technological activity. Perhaps it was a response to some earlier signal from Earth, though no human transmission matched the timing required for such an exchange. Perhaps it marked a routine communication between distant outposts of a galactic civilization, intercepted by chance as Earth passed through the transmission beam. Some researchers speculated about civilizations using powerful directed transmissions for propulsion, beaming energy to spacecraft traveling between star systems. Others considered the possibility of accidental detection of leakage from alien communication networks, signals not intended for external reception, but powerful enough to be detected across interstellar distances. The extraterrestrial hypothesis remained scientifically viable, because it alone could explain all the observed characteristics of the WOW signal without requiring unlikely coincidences or unknown natural phenomena. While the absence of repetition complicated any definitive conclusions, it did not invalidate the possibility of artificial origin. Civilizations might transmit only briefly, conserving energy resources or avoiding detection by hostile species. They might operate on timescales far longer than human attention spans, repeating their signals every few decades or centuries. As the years passed without resolution, the WOW signal settled into a unique position within the scientific discourse about extraterrestrial intelligence. It represented neither proof nor disproof of alien civilizations, but rather a tantalizing suggestion that such proof might be possible. In those 72 seconds of transmission lay the promise that somewhere in the cosmic darkness, intelligence might be trying to make contact, waiting patiently for us to develop the wisdom and technology necessary to answer back. Deep in the heart of every star, in the vast clouds that drift between worlds, and within the very fabric of the cosmos itself, hydrogen atoms dance their eternal quantum ballet. It is the simplest element, consisting of nothing more than a single proton embraced by a single electron. Yet from this fundamental building block springs the complexity of the entire universe. Stars are born from hydrogen, planets form from its ashes, and life itself emerges from the chemical reactions it makes possible. But hydrogen holds another secret, one that reaches across the emptiness between worlds and speaks in a voice that any intelligent civilization must eventually learn to hear. When Jerry Amon discovered the WOW signal at 1420.406 MHz, he was listening to what scientists call the hydrogen line, also known as the 21 centimeter line. This frequency represents far more than a simple radio wavelength. It embodies a universal constant, a cosmic signature, that emerges from the most fundamental physics of matter and energy. To understand why this frequency held such profound significance for SETI researchers, we must journey into the quantum realm, where atoms reveal their secrets through the subtle dance of particles too small to see. Within every hydrogen atom, the electron and proton possess a property called spin, a quantum characteristic that determines their magnetic orientation. Most of the time, these spins are aligned in opposite directions, creating the atom's lowest energy state. But occasionally, through collisions with other particles or absorption of energy, the electron's spin can flip to a line parallel with the proton's spin. This creates a slightly higher energy state, an excited condition that cannot persist indefinitely. When the electron eventually returns to its ground state, flipping its spin back to the opposite orientation, the atom releases the excess energy as electromagnetic radiation. This radiation emerges at a precise frequency, 1420.405751768 MHz, determined by fundamental physical constants that remain the same throughout the universe. This is the hydrogen line, the characteristic signature of the most abundant element in the cosmos. The physics underlying this emission reflects universal truths that any technologically advanced civilization must discover through their scientific development. The transition frequency depends on fundamental constants like Planck's constant, the speed of light, and the magnetic properties of protons and electrons. These values appear to be the same everywhere in the observable universe, making the hydrogen line a truly universal phenomenon that would be recognized by any species that has developed atomic physics and radio astronomy. From an astronomical perspective, the 21 centimeter line revolutionized our understanding of the galaxy's structure and composition. Before its discovery in 1951, astronomers could observe stars and other luminous objects, but remained largely blind to the vast quantities of neutral hydrogen that filled the spaces between stars. The hydrogen line emission revealed these invisible clouds, allowing scientists to map the galaxy's spiral arms and measure the rotation of our cosmic home. The frequency's significance for radio astronomy extends beyond its role in galactic mapping. Neutral hydrogen clouds throughout the universe emit continuously at this frequency, creating a background glow that permeates the cosmos. This emission provides a natural reference point, a cosmic standard that allows astronomers to measure distances, velocities, and the large-scale structure of the universe. Any civilization that developed radio telescopes would inevitably discover this frequency and recognize its fundamental importance. For SETI researchers, the hydrogen line represented what they called a magic frequency, a logical choice for interstellar communication that would be obvious to any scientific civilization. The reasoning was elegantly simple. If you wanted to send a message that would be recognized as artificial by recipients throughout the galaxy, you would choose a frequency that everyone would be monitoring. Since every technologically advanced species would need to study hydrogen to understand their universe, they would all build radio telescopes capable of detecting 21 centimeter radiation. The propagation characteristics of the hydrogen line frequency made it particularly attractive for interstellar communication. Radio waves at this frequency travel through space, with minimal interference from interstellar dust and gas. Unlike shorter wavelengths that can be scattered or absorbed by cosmic debris, 21 centimeter radiation passes relatively unimpeded through the galaxy, maintaining its strength and coherence across vast distances. Earth's atmosphere presents minimal obstacles to hydrogen line radiation, allowing ground-based radio telescopes to detect these signals without the need for space-based receivers. This accessibility means that any planet with a substantial atmosphere could still monitor the hydrogen line from its surface, making it a practical choice for civilizations at various stages of technological development. The frequency also lies within what radio astronomers call the waterhole, a relatively quiet region of the radio spectrum bounded by the hydrogen line at 21 centimeters and the hydroxyl radical lines at 18 centimeters. Between these frequencies, the cosmos generates relatively little natural radio noise, creating a communication window where artificial signals would stand out clearly against the cosmic background. Some researchers suggested that this waterhole might serve as a natural meeting place for galactic communications, a cosmic coffee shop where civilizations might gather to exchange information. The choice of the hydrogen line for the white signal could not have been coincidental, in the opinion of many SETI researchers. Of all the frequencies available across the electromagnetic spectrum, the detection occurred at the one wavelength that held the most significance for any scientific civilization. This seemed to indicate intentional selection, a deliberate choice made by intelligence that understood the universal importance of hydrogen physics. However, the signal's frequency was not exactly the theoretical hydrogen line value. The detected transmission appeared at 1420.356 MHz, shifted slightly from the rest frequency due to relative motion between the source and Earth. This Doppler shift indicated that either the transmitting civilization was located on a planet orbiting a star moving relative to our solar system, or that the signal had been deliberately shifted to a nearby frequency to distinguish it from natural hydrogen emission. The Doppler effect provided astronomers with additional information about the signal's possible origin. By measuring the frequency shift, researchers could calculate the relative velocity between the source and Earth at the time of detection. The observed shift suggested a source moving at approximately 51 km per second relative to our solar system, a velocity consistent with the normal motion of stars within our galactic neighborhood. This velocity measurement helped researchers narrow down potential source locations and eliminate some terrestrial explanations for the signal. If the transmission had originated from Earth-based interference, it would not have shown the Doppler shift characteristic of a distant astronomical source. The frequency displacement provided independent confirmation that the signal came from beyond our planet, though it could not distinguish between natural and artificial origins. The precision of the frequency measurement also impressed researchers familiar with the challenges of interstellar communication. Maintaining a stable transmission frequency across galactic distances required sophisticated engineering, particularly if the signal was intended to remain close to the hydrogen line despite the orbital motion of both transmitter and receiver. This level of frequency control suggested advanced technology, whether natural or artificial. Some scientists wondered whether the slight frequency offset might represent a form of cosmic etiquette, a way of distinguishing artificial signals from the natural hydrogen line emission that pervades the galaxy. By transmitting near but not exactly at the rest frequency of hydrogen, an intelligent civilization could ensure their signals would be detected by astronomers studying the 21-centimeter line, while avoiding interference with natural emissions from interstellar gas clouds. As decades passed without repetition of the WOW signal, the significance of its frequency choice only deepened the mystery. If the signal represented natural phenomena, the hydrogen line frequency was a remarkable coincidence. If it was artificial, the choice demonstrated an understanding of physics and communication theory that aligned perfectly with human expectations for how extraterrestrial intelligence might attempt to make contact. In the quiet hours when radio telescopes still scan the hydrogen line frequency, listening for whispers from distant worlds, the memory of that 72-second transmission continues to haunt researchers. Somewhere in the cosmos, hydrogen atoms continue their eternal dance, releasing 21-centimeter radiation that carries the potential for messages we have yet to decode. And perhaps in that universal frequency that speaks to the fundamental nature of matter and energy, lies the key to understanding whether we truly heard, for just a moment, the voice of another civilization calling across the void. In the months that followed, Jerry Amon's extraordinary discovery, a peculiar kind of waiting began. It was not the eager anticipation of imminent revelation, but rather the patient, methodical vigilance that characterizes all great scientific endeavors. Radio telescopes around the world turned their attention to the coordinates in Sagittarius, their receivers tuned to 1420 MHz, listening for the return of that remarkable signal that had blazed so briefly across the cosmic spectrum. The silence that greeted these efforts was not merely the absence of sound, but something far more profound. It was the silence of unanswered questions, of possibilities left hanging in the vast emptiness between worlds. As days turned to weeks and weeks to months, researchers began to confront a reality that would define the WOW signal's legacy for decades to come. Whatever had transmitted those 72 seconds of extraordinary radio energy had apparently fallen silent, leaving behind only the memory of its brief appearance, and a growing collection of theories about what it might have been. The psychological impact of this silence on the SETI community was both subtle and profound. Jerry Amon himself began to experience a kind of cosmic loneliness, the weight of carrying knowledge that seemed to exist in isolation. He had witnessed something unprecedented, something that might represent humanity's first contact with extraterrestrial intelligence, yet he could not prove it, could not summon it again, could not demonstrate to skeptics that it had been anything more than an elaborate false alarm. Other researchers involved in the search felt similar effects. They had dedicated their careers to listening for signs of intelligence among the stars, motivated by the conviction that such signals must exist somewhere in the vast cosmos. The WOW signal had seemed to vindicate their faith, offering tantalizing evidence that their patient vigil might bear fruit. Its failure to repeat introduced a new kind of uncertainty, a recognition that even genuine extraterrestrial signals might appear only once, like shooting stars that illuminate the sky for an instant before vanishing forever. The continued absence of the signal forced researchers to confront fundamental questions about the nature of interstellar communication and their own expectations about how alien civilizations might behave. Popular science fiction had conditioned many to expect that first contact would involve sustained dialogue, regular transmissions, or at least some form of pattern that could be analyzed and understood. The WOW signal challenged these assumptions, suggesting that the reality of extraterrestrial communication might be far more subtle and elusive than anyone had imagined. As the 1980s progressed, technological advances in radio astronomy offered new hope for relocating the signal or detecting similar transmissions. Digital signal processing replaced analog systems, allowing for more sophisticated analysis of radio data. Computer storage capacity expanded dramatically, enabling researchers to preserve and examine far more information than had been possible when the original signal was detected. Receivers became more sensitive, capable of detecting weaker signals across broader frequency ranges. The Very Large Array in New Mexico, completed in 1980, represented a quantum leap in radio astronomy capability. Its 27 interconnected dishes could simulate a telescope 36 kilometers in diameter, offering unprecedented resolution and sensitivity. When pointed toward the Sagittarius coordinates, the VLA could detect signals thousands of times weaker than those visible to the Big Ear telescope, yet it found nothing where the WOW signal had appeared. Similar efforts at Arecibo in Puerto Rico, with its massive 300-meter dish, yielded equally frustrating results. The giant telescope, capable of detecting signals from the edge of the solar system, found only the familiar whisper of cosmic background radiation when it examined the mysterious coordinates. Each negative result added another layer to the growing enigma, deepening the mystery rather than resolving it. International collaboration. The search reached new levels as researchers recognized that relocating the WOW signal might require coordinated observations across multiple time zones and geographic locations. The signal's brief duration meant that any repetition might be missed by a single observatory, but a global network of telescopes could maintain continuous coverage of the target region. Projects like the Search for Extraterrestrial Intelligence Institute's Targeted Search program began systematically monitoring hundreds of nearby star systems, including those in the direction of the original signal. These expanded efforts revealed both the promise and the limitations of SETI research in the post-WOW signal era. While the technology for detecting artificial signals had improved dramatically, the sheer scale of the search space had also become apparent. The WOW signal might have originated from any of thousands of star systems within its possible range. Even if it repeated on a regular schedule, that schedule might involve intervals of years, decades, or centuries far longer than any human observation program could sustain with focused attention. The concept of one-time events in science became a central theme in discussions about the WOW signal's significance. Throughout the history of scientific discovery, researchers had occasionally encountered phenomena that appeared only once, defying efforts at replication or further study. Gamma-ray bursts, first detected by military satellites in the 1960s, were initially unexplained one-time events that challenged astronomers' understanding of high-energy astrophysics. Only decades of patient observation revealed their true nature as distant cosmic explosions. The WOW signal presented a similar challenge to scientific methodology. The fundamental principle of reproducibility, which demanded that significant discoveries be verified through repeated observation, seemed inadequate when applied to phenomena that might inherently be singular events. If extraterrestrial civilizations transmitted only briefly, or if their signals were highly directional and rarely pointed toward Earth, then expecting repetition might be unrealistic. This realization forced researchers to develop new approaches to evaluating extraordinary claims. Rather than requiring immediate replication, they began to focus on the internal consistency of single detections, analyzing every aspect of the data to determine whether it could be explained by known natural phenomena or terrestrial interference. The WOW signal passed these tests, exhibiting characteristics that remained difficult to explain through conventional means, even as its failure to repeat prevented definitive confirmation of its significance. The patience required for SETI research became a defining characteristic of the field in the decades following the WOW signal. Unlike other branches of astronomy, where new discoveries occurred regularly and observational targets were abundant, SETI demanded a different kind of scientific temperament. Researchers had to maintain enthusiasm and funding for projects that might detect nothing for years or decades, sustained only by the conviction that extraterrestrial intelligence must exist somewhere in the universe. This patience was not passive waiting, but active preparation. Researchers used the quiet years to develop better search strategies, more sensitive equipment, and more sophisticated analysis techniques. They recognized that the next signal, like the WOW transmission, might last only seconds or minutes, requiring rapid response and immediate follow-up observations. The failure to confirm the original signal motivated improvements in detection protocols that would ensure better handling of future discoveries. The possibility that the WOW signal represented a brief, directed transmission never meant to repeat gained credibility as researchers considered the energy requirements for interstellar communication. Broadcasting a signal powerful enough to be detected across hundreds of light-years required enormous amounts of energy, resources that even advanced civilizations might not waste on continuous transmission. Instead, they might send focused beams towards specific targets for limited periods, conserving energy while maximizing the chance of detection by emerging technological civilizations. This scenario suggested that Earth might have been extraordinarily fortunate to intercept the WOW signal during its brief transmission window. Like a lighthouse beam that illuminates ships only when pointed in their direction, the signal might have swept across our solar system for just 72 seconds before continuing on to other targets. The probability of detecting such a transmission would be vanishingly small, making the original detection even more remarkable. As the 20th century drew to a close, the WOW signal had become something more than a scientific anomaly. It represented the tantalizing possibility that humanity was not alone, that somewhere among the stars, intelligence was attempting to communicate across the cosmic void. The silence that followed its detection was not empty, but pregnant with possibility, a reminder that the universe might be stranger and more wonderful than we dared to imagine. In that silence, researchers found not despair, but inspiration to continue listening, knowing that the next signal might be just one observation away. In the decades following the discovery of the WOW signal, a unique community of scientists emerged from the shadows of mainstream astronomy, united by a shared obsession with one of humanity's most profound questions. These were the searchers, the patient listeners, who dedicated their lives to monitoring the cosmic radio spectrum for whispers from distant civilizations. They worked in relative obscurity, often struggling for funding and recognition, sustained only by an unwavering conviction that somewhere among the stars, intelligence was waiting to be discovered. The roots of this community stretched back to 1959, when physicist Giuseppe Cocconi and Philip Morrison published a landmark paper suggesting that extraterrestrial civilizations might communicate using radio waves. Their work inspired Frank Drake to conduct the first systematic search for alien signals in 1960. Using an 85-foot radio telescope at the National Radio Astronomy Observatory in Green Bank, West Virginia, Drake's Project Ozma, named after the ruler of the fictional land of Oz, listened to two nearby sun-like stars for 6 hours each, detecting nothing but cosmic noise. Despite this initial failure, Drake's pioneering effort established the methodology and philosophy that would guide SETI research for decades to come. In 1961, he formulated what became known as the Drake equation, an attempt to estimate the number of communicating extraterrestrial civilizations in our galaxy. The equation considered factors like the rate of star formation, the fraction of stars with planets, and the likelihood that life would develop intelligence and technology. While the equation contained too many unknowns to yield definitive answers, it provided a framework for thinking systematically about the search for extraterrestrial intelligence. The discovery of the WOW signal in 1977 transformed the SETI community from a small group of visionaries into a more organized and ambitious research program. Jerry Amon's detection proved that radio telescopes could potentially detect artificial signals from space, validating the basic assumptions underlying SETI methodology. More importantly, it demonstrated that such signals might be fleeting, appearing only briefly before vanishing back into the cosmic silence. This realization profoundly influenced the next generation of SETI researchers, who understood that their work required not just sophisticated equipment, but also extraordinary patience and persistence. Among the most dedicated was Jill Tarter, an astronomer who became the public face of SETI research, and the inspiration for the protagonist in Carl Sagan's novel, Contact. Tarter spent decades developing new search strategies and technologies, driven by a conviction that the discovery of extraterrestrial intelligence would represent the most significant moment in human history. The personal motivations that drew researchers to SETI work were as varied as the individuals themselves, but certain themes appeared repeatedly. Many described a childhood fascination with the stars and a deep curiosity about humanity's place in the universe. Others were motivated by the profound implications of contact with alien intelligence, recognizing that such a discovery would forever change how humans viewed themselves and their cosmic significance. Some were drawn by the technical challenges of the search, the opportunity to push the boundaries of radio astronomy and signal processing. What united these diverse personalities was a willingness to embrace uncertainty and delayed gratification on a cosmic scale. Unlike other branches of science where discoveries occurred regularly and career advancement followed predictable patterns, SETI research offered no guarantee of success within a human lifetime. Researchers might spend entire careers listening to cosmic static, sustained only by the possibility that the next observation might reveal something extraordinary. The funding challenges facing SETI research reflected both its speculative nature and the political realities of scientific research. Government agencies, particularly NASA, provided sporadic support for SETI projects, but this funding was always vulnerable to budget cuts and political pressure. In 1993, Congress terminated NASA's formal SETI program, forcing researchers to seek private funding for their work. The cancellation reflected public skepticism about spending taxpayer money to search for little green men, despite the serious scientific methodology underlying the research. The formation of the SETI Institute in 1984 represented the community's response to these funding challenges, creating a dedicated organization focused specifically on the search for extraterrestrial intelligence. Founded by Frank Drake, Jill Tarter, and other SETI pioneers, the Institute sought private donations and corporate sponsorship to support research that government agencies were reluctant to fund. This transition from government to private support gave SETI researchers greater independence, but also required them to become fundraisers and public educators, explaining their work to skeptical audiences who often confused serious science with science fiction. The personal toll of SETI research became apparent as the field matured, and researchers began to confront the possibility that they might never detect another signal like the WOW transmission. The work demanded a particular psychological profile, the ability to maintain enthusiasm and scientific rigor despite repeated disappointment. Many SETI researchers developed coping mechanisms that resembled those of other professions requiring long-term commitment, without immediate rewards, finding satisfaction in incremental progress and technological improvements rather than dramatic discoveries. Some researchers struggled with the isolation that came with working in such a specialized field. SETI occupied an unusual position within the scientific community, respected for its rigorous methodology, but often viewed with suspicion due to its association with UFO enthusiasts and popular culture. Serious SETI researchers had to constantly distinguish their work from less scientific approaches to the question of extraterrestrial life, maintaining careful boundaries between evidence-based research and speculation. The WOW signal profoundly influenced how SETI researchers approached their work, leading to significant improvements in detection protocols and analysis techniques. The failure to confirm the original signal highlighted the importance of immediate follow-up observations and real-time data sharing between facilities. New search programs incorporated rapid response capabilities, ensuring that unusual signals could be quickly verified or refuted before they disappeared. Technological development in SETI research accelerated following the WOW signal discovery, as researchers recognized the need for more sensitive equipment and sophisticated analysis tools. Digital signal processing replaced analog systems, allowing for more precise frequency analysis and better interference rejection. Computer networks enabled real-time coordination between observatories, creating the possibility of simultaneous observations from multiple locations. The signal also influenced public interest in SETI research, providing a tangible example of what the search might discover. Unlike theoretical discussions about the Drake equation, or statistical arguments about the likelihood of extraterrestrial intelligence, the WOW signal offered something concrete, a specific event that demonstrated the potential reality of alien communication. This helped SETI researchers communicate their work to the public and attract the private funding necessary to continue their research. As the SETI community evolved, researchers began to grapple with deeper questions about what finding another signal would mean for humanity. The discovery of extraterrestrial intelligence would represent more than a scientific breakthrough. It would fundamentally challenge human assumptions about our uniqueness and significance in the universe. Some researchers worried about the social and psychological impact of such a discovery, while others believed it would inspire humanity to overcome its divisions and work together as a species. The philosophical implications of SETI research attracted researchers from diverse backgrounds, including anthropologists, linguists, and philosophers who recognized that contact with alien intelligence would raise questions far beyond the realm of astronomy and physics. How would humanity decode messages from a completely alien mind? What would such communication reveal about the nature of intelligence itself? How would different cultures and religions respond to the knowledge that we are not alone? These questions remained largely theoretical, as long as the WOW signal stood alone, an isolated anomaly in decades of otherwise silent observation. Yet the community of searchers persisted, motivated by the conviction that the universe was too vast and old for Earth to be the only world harboring intelligence. They continued to listen, to improve their techniques, and to prepare for the day when another signal might break the cosmic silence and transform our understanding of our place among the stars. In the quiet hours when radio telescopes scan the sky, these dedicated researchers maintain their vigil, knowing that their work represents one of humanity's most ambitious endeavors. They search not just for signals but for meaning, for connection, for answers to questions that have haunted our species since we first looked up at the night sky and wondered if anyone was looking back. In the years following Jerry Amon's discovery, something remarkable happened to the WOW signal that had nothing to do with radio telescopes or scientific analysis. The mysterious transmission began to take on a life of its own in the collective imagination, spreading beyond the confines of academic journals and research conferences to capture the attention of writers, filmmakers, and dreamers around the world. What had begun as 72 seconds of anomalous radio data gradually transformed into something much larger, a cultural touchstone that embodied humanity's deepest questions about our place in the universe. The signal's journey into popular consciousness began modestly, with brief mentions in science magazines and astronomy newsletters. Unlike dramatic discoveries that made front-page headlines, the WOW signal emerged slowly into public awareness, its significance becoming apparent only as researchers failed to find conventional explanations for its extraordinary characteristics. This gradual revelation suited the signal's enigmatic nature, creating a sense of mystery that proved irresistible to storytellers and the public alike. Science fiction writers were among the first to recognize the narrative potential of the WOW signal. Here was a real astronomical event that seemed lifted directly from the pages of speculative fiction, a genuine mystery that suggested humanity might not be alone in the universe. Authors began incorporating the signal into their stories, sometimes as background detail lending authenticity to their fictional worlds, other times as the central mystery driving entire plots. Carl Sagan's novel Contact, published in 1985, drew heavily from the real-world experience of SETI researchers, including the tantalizing possibility represented by signals like the WOW detection. While Sagan's fictional transmission was far more elaborate and sustained than the brief Ohio signal, the underlying premise reflected the same questions that haunted researchers in the wake of Amon's discovery. What would it mean to receive a message from another world? How would humanity respond to such contact? The subsequent film adaptation of Contact in 1997 brought these questions to an even broader audience, introducing millions of viewers to the patient, methodical work of SETI research and the profound implications of detecting artificial signals from space. The movie's portrayal of radio astronomers listening for extraterrestrial transmissions drew directly from the real experiences of researchers who had dedicated their careers to this quest, lending authenticity to what might otherwise have seemed like pure fantasy. Documentary filmmakers also found the WOW signal irresistible as a subject for exploration. Unlike other SETI topics that required extensive explanation of theoretical concepts, the signal offered a concrete event that viewers could easily grasp. Television programs about the search for extraterrestrial intelligence invariably featured segments about the mysterious Ohio transmission, often accompanied by dramatic reenactments of Jerry Amon examining computer printouts and writing that famous exclamation in the margin. These documentaries served a dual purpose, entertaining audiences while educating them about the serious scientific methodology underlying SETI research. However, they also created challenges for researchers who sometimes found their work sensationalized or misrepresented. The tension between scientific accuracy and dramatic storytelling became a constant concern for SETI scientists who recognized the importance of public interest while worrying about misconceptions that might undermine their credibility. The internet age brought new opportunities and challenges for public understanding of the WOW signal. Online forums, websites, and social media platforms allowed enthusiasts to share information and theories about the mysterious transmission, creating communities of amateur researchers who analyzed every aspect of the detection. While this democratization of information spreading helped maintain public interest in SETI research, it also led to the proliferation of speculation and misinformation that complicated efforts to maintain scientific accuracy. Conspiracy theories inevitably emerged around the WOW signal, with some suggesting that government agencies had suppressed additional information about the transmission, or that follow-up detections had been classified. These theories reflected broader public suspicion about official secrecy regarding extraterrestrial phenomena, though they found little support among the researchers who had actually worked on the signal's analysis. The open publication of all relevant data and the transparent efforts to relocate the signal contradicted claims of government cover-up. But such evidence rarely deterred committed conspiracy theorists. The signal's influence on popular music, art, and literature extended far beyond science fiction and documentaries. Musicians composed pieces inspired by the mysterious transmission, artists created visual representations of its data patterns, and poets found metaphorical meaning in humanity's brief encounter with the possibly impossible. The WOW signal became a cultural symbol, representing not just the search for extraterrestrial intelligence, but humanity's broader quest for meaning and connection in an apparently vast and empty universe. Educational institutions began incorporating the WOW signal into curricula, ranging from astronomy courses to discussions of scientific methodology and critical thinking. The signal provided an excellent case study in how scientists approach extraordinary claims, demonstrating the importance of careful analysis, peer review, and the provisional nature of scientific conclusions. Students could examine the actual data, consider various explanations, and grapple with the challenges of drawing definitive conclusions from ambiguous evidence. The signal's role in maintaining public support for SETI research proved crucial during periods when government funding was threatened or eliminated. When Congress cancelled NASA's formal SETI program in 1993, public interest in the WOW signal and similar mysteries helped generate private funding that allowed the research to continue. The signal served as a tangible example of what SETI might accomplish, providing a concrete justification for continued investment in the search for extraterrestrial intelligence. Media coverage of the signal evolved significantly over the decades, reflecting changes in both scientific understanding and public attitudes toward the possibility of extraterrestrial life. Early reports often treated the signal as either a certain sign of alien intelligence or a probable false alarm, reflecting the polarized nature of public discourse about UFOs and extraterrestrial phenomena. Later coverage became more nuanced, acknowledging the signal's extraordinary characteristics, while recognizing the limitations of drawing definitive conclusions from a single, unrepeated detection. The rise of social media created new dynamics in how the public engaged with the WOW signal and SETI research more generally. Twitter, Facebook, and YouTube allowed researchers to communicate directly with interested audiences, bypassing traditional media filters that sometimes distorted or sensationalized their work. However, these platforms also amplified misinformation and conspiracy theories, creating new challenges for maintaining accurate public understanding of the scientific evidence and methodology. Misconceptions about the WOW signal proliferated in popular culture, often reflecting broader misunderstandings about how science works and what constitutes evidence for extraordinary claims. Some people believed the signal had been definitively proven to be of extraterrestrial origin, while others dismissed it as obviously terrestrial interference. Both extremes missed the more nuanced reality that the signal remained genuinely unexplained, neither proven to be alien nor convincingly attributed to natural or human sources. SETI researchers worked continuously to correct these misconceptions while acknowledging the profound implications that would follow if the signal truly represented extraterrestrial communication. They emphasized that extraordinary claims required extraordinary evidence, but also that the absence of conventional explanations made the signal worthy of continued attention and analysis. This balanced approach reflected the scientific method's emphasis on evidence-based conclusions while remaining open to revolutionary possibilities. The WOW signal's cultural impact extended beyond entertainment and education to influence public policy and scientific priorities. Politicians and science administrators who might otherwise have viewed SETI research as frivolous found themselves confronted with evidence that such searches could potentially yield results. The signal provided concrete justification for radio astronomy funding and helped legitimize the search for extraterrestrial intelligence as a serious scientific endeavor worthy of institutional support. As the signal's cultural influence grew, it began to shape how people thought about humanity's relationship with the cosmos and our responsibilities as a potentially emerging technological civilization. The possibility that we had briefly heard from another world raised questions about what we might want to say in return, how we should prepare for more sustained contact, and what our detection of their signal might mean for civilizations trying to communicate across the galaxy. In the quiet moments when the world paused to consider these profound questions, the WOW signal served as more than just a scientific curiosity. It became a mirror reflecting our deepest hopes and fears about cosmic solitude, a reminder that the universe might be stranger and more wonderful than we dared to imagine, and a call to continue listening for voices in the cosmic darkness, wherever they might arise. In the digital age that dawned in the decades following Jerry Ammon's discovery, the search for extraterrestrial intelligence underwent a transformation as profound as the signal itself. The humble computer printouts and manual analysis that characterized SETI research in 1977 gave way to sophisticated networks of interconnected telescopes, automated detection systems, and processing power that would have seemed like science fiction to the researchers who first identified the WOW signal. Yet, beneath all this technological advancement, lay the same patient hope that had motivated those early searchers. The same quiet conviction that somewhere in the cosmic darkness, intelligence might be waiting to make contact. The revolution began with the recognition that SETI research required computational resources far beyond what any single institution could provide. The analysis of radio telescope data involved searching through vast datasets for subtle patterns that might indicate artificial signals, a task perfectly suited to the parallel processing capabilities of modern computer networks. In 1999, researchers at the University of California, Berkeley launched SETI at Home, a distributed computing project that harnessed the idle processing time of personal computers around the world to analyze data from the Arecibo radio telescope. The concept was elegantly simple yet revolutionary in its implications. When computer users installed the SETI at Home software, their machines would automatically download packets of radio telescope data during periods of inactivity, analyzing the information for signs of artificial signals before uploading the results, and requesting new data to examine. Within months of its launch, SETI at Home had recruited hundreds of thousands of volunteers, creating a virtual supercomputer more powerful than any centralized system that researchers could have afforded. This distributed approach to signal analysis represented more than just a technological advancement. It embodied a democratization of the search for extraterrestrial intelligence. Ordinary citizens could participate directly in SETI research, contributing their computational resources to humanity's greatest quest for cosmic companionship. The project's success inspired similar efforts in other scientific disciplines, proving that complex research problems could benefit from the collective power of distributed computing networks. The data being analyzed by these volunteer computers came from increasingly sophisticated radio telescopes that had learned important lessons from the experience of the WOW signal. Modern SETI projects incorporated multiple beam receivers that could monitor hundreds of frequency channels simultaneously, dramatically increasing the probability of detecting brief, intermittent transmissions. Real-time processing systems replaced the delayed analysis that had characterized the original WOW discovery, ensuring that interesting signals could be immediately flagged for follow-up observation. Digital signal processing techniques developed in the decades following the WOW detection allowed researchers to extract far more information from radio telescope data than had been possible with the analog systems of the 1970s. Software algorithms could automatically identify and reject terrestrial interference, distinguish between natural and potentially artificial signals, and detect patterns that might escape human analysis. These systems operated continuously, monitoring the cosmic radio spectrum with a sensitivity and persistence that no human observer could match. The sensitivity improvements in modern radio telescopes represented perhaps the most dramatic advancement in SETI capability since the field's inception. The Allen Telescope Array, dedicated specifically to SETI research and completed in 2007, consisted of 42 6-meter dishes working together to create a powerful instrument optimized for the search for artificial signals. Unlike general-purpose radio telescopes that divided their time between many different research projects, the Allen Array could devote its full attention to SETI observations, monitoring thousands of star systems simultaneously. International collaboration in SETI research reached unprecedented levels, as researchers recognized that detecting and confirming extraterrestrial signals required global coordination. The International Academy of Astronautics developed protocols for sharing information about potential discoveries, ensuring that multiple facilities could quickly verify interesting detections before they disappeared. High-speed internet connections enabled real-time data sharing between observatories on different continents, creating a global network of telescopes that could respond to discoveries within minutes. These collaborative networks proved their value in 2007 when researchers detected a series of unusual signals that initially appeared to be of artificial origin. Within hours, observatories around the world were examining the same coordinates, ruling out local interference and confirming that the signals originated from space. Though the transmissions were eventually identified as natural phenomena called fast radio bursts, the rapid international response demonstrated how modern SETI research had evolved since the isolated discovery of the WOW signal. Machine learning algorithms, introduced in the 21st century, offered new approaches to analyzing the vast quantities of data generated by modern radio telescopes. These systems could learn to recognize patterns in radio signals that might indicate artificial origin, potentially identifying types of transmissions that human researchers had never considered. Neural networks trained on decades of radio astronomy data could distinguish between known natural sources and anomalous signals that deserved closer examination, automating much of the tedious analysis work that had previously required human attention. The application of artificial intelligence to SETI research raised intriguing philosophical questions about using machine intelligence to search for alien intelligence. Computer algorithms might detect patterns that human minds could not perceive, but they might also miss subtleties that only conscious beings could appreciate. The most sophisticated SETI systems combined automated processing with human oversight, using computers to handle routine analysis, while preserving human judgment for evaluating truly unusual discoveries. Modern projects specifically designed to detect WOW-type signals incorporated hard-won lessons from the original detection's limitations. The Breakthrough Listen initiative, launched in 2015, with $100 million in funding, employed multiple telescopes simultaneously to ensure that interesting signals could be immediately verified. The project's protocols required that any candidate signal be detected by at least 2 independent receivers before being considered significant, preventing false alarms caused by equipment malfunctions or local interference. The frequency coverage of modern SETI searches far exceeded what had been possible in 1977. Instead of monitoring single frequencies like the hydrogen line, contemporary projects could simultaneously analyze millions of frequency channels across broad ranges of the electromagnetic spectrum. This comprehensive approach recognized that extraterrestrial civilizations might choose communication frequencies that differed from human expectations, requiring a more systematic survey of the radio spectrum. Real-time analysis capabilities meant that modern SETI systems could respond to interesting detections within seconds rather than days. Automated alert systems could immediately notify researchers around the world when anomalous signals were detected, triggering coordinated observations from multiple facilities before the transmission could fade or disappear. This rapid response capability addressed one of the most frustrating aspects of the original WOW signal: the 3-day delay between detection and recognition that prevented immediate follow-up. The integration of optical and radio observations represented another significant advancement in modern SETI methodology. Researchers recognized that truly advanced civilizations might use multiple communication channels simultaneously, perhaps combining radio transmissions with laser signals or other forms of electromagnetic radiation. Contemporary searchers increasingly coordinated observations across the entire electromagnetic spectrum, looking for correlations that might indicate artificial coordination between different types of signals. Space-based SETI observations offered advantages that ground-based telescopes could never achieve. Satellites and space telescopes could monitor frequencies blocked by Earth's atmosphere, extend observations to wavelengths impossible to detect from the surface, and avoid the terrestrial interference that increasingly contaminated ground-based radio astronomy. While such missions remained expensive and technically challenging, they represented the future of SETI research as Earth's radio environment became increasingly noisy. The data storage and preservation capabilities of modern SETI projects ensured that discoveries like the WOW signal would never again be lost to technological limitations. Digital archives could preserve raw radio telescope data indefinitely, allowing future researchers to reanalyze historical observations using more sophisticated techniques. This permanent preservation meant that even signals detected decades ago could continue yielding new insights as analysis methods improved. As SETI research entered the 21st century, the tools available to researchers had become almost unimaginably more powerful than those used by Jerry Arman in 1977. Yet the fundamental challenge remained the same: finding artificial patterns in the vast noise of the cosmic radio spectrum. Modern technology had made the search more systematic, more sensitive, and more comprehensive, but it had not made it any less dependent on patience, persistence, and the quiet hope that somewhere among the stars, someone might be trying to call. In the decades since Jerry Amon circled those 6 alphanumeric characters and wrote his famous exclamation, the WOW signal has evolved into something far more significant than a mere astronomical anomaly. It has become a mirror in which humanity sees reflected its deepest questions about cosmic solitude, a Rorschach test in radio waves that reveals as much about our hopes and fears as it does about the mysterious transmission itself. Whether the signal originated from an alien civilization, a previously unknown natural phenomenon, or some mundane terrestrial source, may ultimately matter less than what it has taught us about ourselves and our place in the vast cosmic order. The signal forces us to confront fundamental questions that have haunted human consciousness since we first developed the capacity for abstract thought. Are we alone in the universe, the only intelligence to emerge from billions of years of cosmic evolution, or are we merely one voice in a vast galactic chorus, a newcomer to an ancient community of minds scattered among the stars? The WOW signal offers no definitive answers to these questions, but its very existence demands that we grapple seriously with their implications. The human response to the possibility of extraterrestrial intelligence reveals deep-seated assumptions about our own nature and significance. For some, the prospect of cosmic companionship represents the fulfillment of humanity's greatest dreams, the confirmation that intelligence and consciousness are not rare accidents but inevitable products of a universe evolving toward complexity and awareness. These optimists see in signals like the WOW transmission evidence that we are part of something larger than our small planet, members of a cosmic community that spans the galaxy. Others find the possibility more disturbing, challenging as it does our traditional understanding of human uniqueness and centrality in the cosmic scheme. If intelligence has emerged independently elsewhere in the universe, what does that say about our special relationship with the divine, our role as the pinnacle of creation, our assumption that the universe was designed specifically for our benefit? The WOW signal, in its mysterious silence, forces us to confront the possibility that we are neither unique nor central, but simply one experiment in consciousness among many. The scientific community's response to the signal illuminates the complex relationship between evidence and belief, between the desire to make revolutionary discoveries and the need to maintain rigorous standards of proof. The principle that extraordinary claims require extraordinary evidence has served science well, protecting the field from premature acceptance of dramatic but unsupported hypotheses. Yet this conservative approach creates a paradox when applied to phenomena like the WOW signal that might genuinely represent extraordinary reality. The signal exists in what philosophers call a liminal space, neither proven nor disproven, neither fully accepted nor completely rejected. It possesses characteristics that make it difficult to explain through conventional means, yet it lacks the repeatability and verification that would convince skeptics of its significance. This ambiguous status reflects the challenges inherent in studying phenomena that might be genuinely unprecedented, events that by their very nature resist the standard methods of scientific confirmation. The WOW signal also serves as a meditation on the nature of communication itself and humanity's readiness to participate in interstellar dialogue. If the transmission did originate from another civilization, what does our failure to respond say about our species? We detected a possible message from the stars and then spent decades arguing about whether it was real rather than crafting a response. This pattern reflects broader human tendencies toward discord and disagreement, suggesting that we may not yet be mature enough as a species to engage in meaningful exchange with alien intelligence. The signal raises profound questions about the ethics and responsibility of interstellar communication. If advanced civilizations are indeed transmitting messages to emerging worlds like Earth, What obligations do we have to listen carefully, respond thoughtfully, and preserve these communications for future generations? The casual dismissal of the wow signal by some skeptics might represent a lost opportunity of cosmic proportions, a failure to recognize and honor our first contact with minds beyond our world. Conversely, the signal's lack of repetition might reflect the wisdom of advanced civilizations who understand that premature contact could be disruptive to developing species. Perhaps alien intelligence operates according to protocols we cannot yet comprehend, sending brief signals to test our readiness for more sustained communication. The wow signal might represent a kind of cosmic examination, a probe to determine whether humanity has achieved sufficient technological and social maturity to join a galactic community. The psychological impact of the signal on those who study it reveals the profound human need for cosmic connection and meaning. SETI researchers often describe their work in quasi-religious terms, speaking of faith, patience, and the transformative potential of contact with alien intelligence. The wow signal feeds this spiritual dimension of the search, providing a tangible focus for hopes and dreams that might otherwise remain abstract. It represents the possibility of transcendence, of moving beyond our terrestrial limitations to join something larger and more significant. The signal also reflects humanity's relationship with mystery and the unknown. In an age where scientific knowledge has expanded exponentially and technological capabilities seem to grow daily, genuine mysteries have become increasingly rare. The wow signal preserves a space for wonder and speculation, a reminder that the universe still holds secrets beyond our current understanding. This preservation of mystery serves an important psychological function, maintaining humility in the face of the cosmic vastness, and preventing the arrogance that might come from assuming we already understand all the fundamental principles governing reality. Cultural responses to the signal reveal deep divisions in how different groups approach the possibility of extraterrestrial intelligence. Scientists tend to emphasize the need for rigorous analysis and reproducible evidence, while popular culture often embraces the signal as proof of alien contact, regardless of scientific uncertainties. Religious communities vary in their responses, with some seeing potential extraterrestrial intelligence as evidence of divine creativity and others viewing it as a challenge to traditional theological frameworks. These varied responses highlight the signal's role as a catalyst for broader discussions about humanity's cosmic perspective and future development. The mere possibility that the transmission represents alien intelligence forces us to consider how contact with such beings might transform human society's scientific understanding and philosophical frameworks. Would confirmation of extraterrestrial intelligence unite humanity around our common cosmic heritage? Or would it create new divisions based on different interpretations of the contact's meaning? The wow signal's enduring significance may lie not in whether it ever receives scientific confirmation, but in how it continues to inspire human imagination and scientific inquiry. It represents the possibility of breakthrough, the hope that our patient listening might eventually yield profound revelations about the nature of intelligence and its distribution throughout the universe. Even if the signal ultimately proves to be of terrestrial or natural origin, its role in motivating continued SETI research and public interest in astrobiology ensures its historical importance. The signal embodies the quintessentially human desire to reach beyond our immediate environment and connect with something greater than ourselves. This drive toward transcendence, toward contact with the other, represents one of our species' most noble characteristics. Whether channeled through scientific research, artistic expression, or spiritual practice, this impulse reflects our deepest understanding that consciousness and intelligence represent precious phenomena worthy of preservation and celebration wherever they might arise. As we continue to listen for additional signals from the cosmic radio spectrum, the wow transmission remains a reminder of what might be possible, a whisper of hope in the vast silence of space. It challenges us to remain open to extraordinary possibilities while maintaining the intellectual rigor necessary to distinguish genuine discoveries from wishful thinking. In this delicate balance between skepticism and wonder lies perhaps the greatest lesson the signal offers, that the search for truth, whether in the laboratory or among the stars, requires both careful methodology and the courage to embrace revolutionary possibilities when the evidence demands it. In radio observatories around the world, the quiet vigil continues. Through changing seasons and passing years, through technological revolutions and generational transitions, the great dishes turn slowly toward the stars. Their receivers tuned to frequencies where artificial signals might hide. Among the cosmic whispers, the astronomers and technicians who tend these instruments carry forward a tradition that began long before Jerry Amen discovered his famous sequence of characters, a patient dedication to listening that the wow signal has both validated and intensified. The influence of that singular detection permeates every aspect of modern SETI research, shaping not just the technical specifications of search programs, but the philosophical approach that guides them. Contemporary researchers operate with the hard-won knowledge that extraordinary signals can appear without warning and vanish just as quickly, leaving behind only traces in computer memory, and the haunting possibility that humanity has missed its greatest opportunity for cosmic contact. This awareness has transformed how SETI projects approach their work, creating a sense of urgency balanced against the need for methodical thoroughness. Every unusual reading in the data stream receives immediate attention. Every anomalous spike in the radio spectrum triggers automated alerts that can summon researchers from sleep or meetings. The fear of missing another wow signal drives a level of vigilance that would have seemed impossible to maintain in the more leisurely days of early radio astronomy. The researchers who dedicate their lives to this listening possess a particular kind of courage, the willingness to spend entire careers pursuing signals that may never come. They work in shifts around the clock, monitoring data streams that flow endlessly from telescopes pointed at thousands of target stars. Their days are filled with the routine examination of computer screens displaying frequency plots and signal strength measurements, searching for patterns that break the monotonous rhythm of cosmic background noise. These modern searchers understand that their work extends far beyond the simple detection of artificial signals. They serve as guardians of one of humanity's most profound quests, maintaining the technological and intellectual infrastructure necessary to recognize and respond to contact from other worlds. Their patience is not passive waiting, but active preparation, the constant refinement of techniques and equipment that might make the difference between detecting the next wow signal and missing it entirely. The scale of the search space they confront defies easy comprehension. Our galaxy contains hundreds of billions of stars, many accompanied by planetary systems that might harbor life and intelligence. Even limiting the search to sun-like stars within a few hundred light-years of Earth leaves millions of potential targets, each requiring observation across thousands of frequency channels and extended periods of time. The probability that any given observation will yield a positive detection remains vanishingly small, yet the cumulative effect of persistent searching offers genuine hope for eventual success. The possibility that similar signals have been missed haunts contemporary SETI researchers with both regret and motivation. Analysis of historical radio astronomy data occasionally reveals anomalous readings that might have been artificial signals, buried in archives and overlooked by observers focused on other phenomena. The fast radio bursts discovered in recent decades remind researchers how easily unusual cosmic phenomena can escape notice, hidden in data that received only cursory analysis at the time of collection. This recognition has led to the development of sophisticated data mining techniques that systematically re-examine archived observations with the benefit of modern analysis methods. Artificial intelligence algorithms trained to recognize potentially artificial signals scan through decades of stored radio telescope data, searching for patterns that human observers might have missed. These efforts occasionally yield intriguing candidates, signals that exhibit some characteristics consistent with artificial origin, but lack the clear provenance necessary for definitive identification. The technical improvements in detection methods since the WOW signal have been revolutionary, yet researchers remain humbled by the vastness of the search space and the subtlety of the task. Modern radio telescopes can simultaneously monitor thousands of frequency channels across broad regions of sky, but they still sample only a tiny fraction of the possible combinations of location, frequency, and time that might yield artificial signals. The search resembles looking for a specific grain of sand on an infinite beach, guided only by theoretical predictions about what such grains might look like. Real-time signal processing capabilities mean that contemporary SETI projects can respond to interesting detections within seconds, automatically triggering follow-up observations from multiple telescopes before unusual signals can fade. This rapid response addresses one of the most frustrating aspects of the original WOW signal: the delay between detection and recognition that prevented immediate verification. Yet even with these improvements, the fundamental challenge remains unchanged. distinguishing artificial intelligence from the myriad natural phenomena that populate the cosmic radio spectrum. The philosophical patience required for SETI work sets it apart from other scientific disciplines where progress can be measured in regular publications and steady accumulation of knowledge. SETI researchers must maintain enthusiasm and scientific rigor despite the possibility that their entire careers might pass without detecting a single artificial signal. They find motivation not in guaranteed results but in the profound importance of the question they pursue, and the recognition that even negative results contribute valuable knowledge about the prevalence of intelligence in the universe. This patience extends beyond individual researchers to encompass entire institutions and funding agencies that must support decades of searching without immediate returns on investment. The survival of SETI programs through periods of government skepticism and budget cuts testifies to a collective human commitment to answering fundamental questions about our cosmic context, regardless of how long such answers might take to emerge. The WOW signal serves as both inspiration and caution for contemporary researchers, a reminder of what remains possible while highlighting the challenges of confirming extraordinary discoveries. It validates the basic methodology of SETI research, proving that radio telescopes can detect artificial signals from space, while simultaneously demonstrating how difficult such signals are to verify and study. Every researcher who examines anomalous data wonders whether they might be looking at another WOW signal, a genuine transmission from another world that could revolutionize human understanding of our place in the universe. Educational programs increasingly incorporate the WOW signal into curricula designed to teach students about scientific methodology, critical thinking, and the challenges of studying rare phenomena. The signal provides an excellent case study in how scientists approach extraordinary claims, balancing skepticism with openness to revolutionary possibilities. Students learn to analyze the actual data, consider various explanations, and grapple with the ambiguity that characterizes many important scientific questions. International cooperation in SETI research has expanded significantly since the WOW signal's discovery, driven partly by recognition that confirming such detections requires coordinated observations from multiple facilities. The protocols developed for sharing information about potential discoveries ensure that interesting signals can be rapidly verified or refuted before they disappear. This global network of researchers and telescopes represents humanity's collective commitment to the search, transcending national boundaries in pursuit of answers to universal questions. As technology continues to advance and new radio telescopes come online, the sensitivity and scope of SETI searches will expand dramatically. Projects planned for the coming decades will monitor millions of stars simultaneously across vast ranges of the electromagnetic spectrum, increasing by orders of magnitude the probability of detecting artificial signals. Yet even these ambitious programs will require the same patient dedication that has characterized SETI research since its inception. The willingness to listen carefully to the cosmos regardless of how long genuine answers might take to arrive. In the quiet hours when the world sleeps and radio telescopes continue their automated scanning of the sky, the spirit of Jerry Amon's discovery lives on. Somewhere in the data streams flowing from these instruments might lie the next WOW signal, waiting for a careful observer to notice its extraordinary characteristics and recognize its profound implications. The search continues, not because success is guaranteed, but because the questions it addresses touch the deepest aspects of human curiosity and our need to understand our relationship with the vast cosmos that surrounds us. In a quiet room in Ohio, on an August morning in 1977, Jerry Amon held in his hands a computer printout that might have changed everything. 6 characters and a single exclamation, circled in red ink, captured in that moment humanity's eternal dance between skepticism and wonder, between the known and the unknowable. Nearly half a century has passed since those 72 seconds of extraordinary radio energy blazed across our receivers. The signal has never returned, never revealed its secrets, never answered the questions it so tantalizingly raised. Yet its silence has taught us something profound about ourselves and our relationship with the cosmos that surrounds us. Perhaps the WOW signal's greatest gift was not proof of extraterrestrial intelligence, but proof of human intelligence, our capacity to listen carefully to the universe and recognize when something extraordinary might be speaking. In that recognition lies our deepest humanity, our refusal to accept cosmic solitude without at least trying to hear if anyone else is out there. Tonight, as you settle into sleep, radio telescopes still turn toward the stars, Their receivers still tune to frequencies where whispers from other worlds might hide. Computers still process endless streams of cosmic data, and researchers still hope for another moment of wonder. The greatest secrets of the universe may not lie in what we eventually discover, but in our willingness to keep listening, to remain open to the impossible, to maintain our vigil among the stars. Good night.